Good evening to all. Today, the day 4 class discuss about the foundations. What type of foundations you use in your buildings? Normal residential buildings. First of all, types of foundation. First of all, you know the two types of foundation. One is a shallow. Another one is a deep foundation. There are two types of foundation is there. One is a shallow foundation. Another one is a deep foundation. Now let's discuss about the shallow foundations. Okay. First of all, discuss about the shallow foundation. The shallow types of shallow foundation means the first one is the isolated footing. The first one is the isolated footing. Then second one is the combined footing. The next one is a mat or raft footing. And next one is a eccentric footings. Okay. The next one is the last one is a eccentric footing. This is the common types of four footings used in your any residential buildings. Okay, it's a normal four footings. There one is a isolated footing, another one is a combined mat or raft, eccentric footing. I tell about how to identify your isolated footing. In simple example, the single column acting on this isolated is called isolated footing. This is our simply draw my pedestal. Okay. This is my pedestal. Only single column. This is our rectangular column. This is single column. This is called isolated footing. Only single column acting on your pedestal is called isolated footing. Next one, second one is a combined footing. The next one is a combined one. The next one, second type is a combined footing. The combined footings, two columns. Okay, two column will be acting on this footing, that is called combined footing. Two column. I simply draw my pedestal. This is my pedestal. Combined footing, two columns. Simply this is single column for isolated. The two columns acting on your pedestal is called combined footing. It's an easy one. How to identify your single isolated footing? The combined footing, the isolated footing is a single column acting on pedestal. Then combined footing is a acting on two columns. The next one, mat or raft. The mat or raft is a more than two footings, more than two columns. Okay, more than two columns. It's as a mat or raft. More than two columns, more than two or three or four, even anyone, etc. That is called mat or raft. Even more than two. The two means acting as a combined footing. More than two means it's as a mat or raft footing. The next one is the eccentric footing. The eccentric is a corner footings. Okay, eccentric is a corner footing for your building. I simply show the example for eccentric mat or raft. This is our pedestal. More than two columns. Is 1, 2, 3, 4, 5, 6 columns. More than two means any number of columns. My building is a 6 columns acting on this one pedestal. That is called mat or raft. Okay, that is the third one is important one. The third one is a mat or raft. More than two columns. Okay, two columns acting on the mat or raft. This is the isolated footing. This is a combined footing. Combined footing. This is a mat or raft footing. Now it's clear how to identify your footing. The next footing is a mat or raft. The next one is a eccentric footing. The eccentric footing is a corner footings. Okay, the eccentric footing is a corner footing. I simply draw my one pedestal, then I column put in this corner. This is called eccentric footing. Okay, now it's clear. This is the identify your shallow foundation. The isolated footing means only single column. Combined means two columns. Then more than two means it's considered as a mat or raft. Then eccentric means it's a corner column. Okay, now it's clear how to identify your different types of columns. Okay, then next one. First step is how to identify your column. Then what are the basics test and how to choose your foundation for this area. How to choose your type of footing. That is the main one. Okay, let's discuss about how to choose your footing for your building conditions. Next step, choosing for your building conditions. See this, I show that how to choose the select the proper type of footings. Okay, how to select the proper type of footing for your building. The first thing is that a supporting soil by bearing capacity. Okay, the first one is a bearing capacity. How to calculate the your footing means how to calculate the first point is a how to calculate your footing means you need the load. This is our column, this is our pedestal. Okay, then you will be calculated the how much load acting on your column, then moment also, then moment you calculated the moment, then upward pressure, say SBC, safe bearing capacity. Once you calculated your footing, you calculated a moment and load for your column, then upward pressure and safe bearing capacity. Okay, base care, sorry, safe bearing capacity for your soil. That is the main important one. Calculated upward is a load and moment, the downward, the bottom force is a SBC. The SBC based on your soil condition. Understand it. The SBC based on your soil condition. You go for a rock soil. Rock soil means you go for SBC is 250 kilonewton per meter cube. You go for clay soil, that type of soil, you will be 130 kilonewton per meter cube. That type of the SBC will be different. Okay, this is the SBC. Simple example. How to identify your SBC will be high. What will changes in your pedestal? Simple one. What changes in your pedestal? For example, my SBC is a SBC. For example, my SBC is a 250. Okay, my safe bearing capacity 250. I put my pedestal size based on my load condition, moment condition. I simply my put on pedestal size is a 4 feet by 4 feet. My pedestal size. Another condition, my SBC. My SBC is a 150. My SBC is a 150. It's automatically it's changed my pedestal size also. This change may based on your calculation. It's go for 8 feet or 10 feet by 10 feet based on your SBC. The pedestal will be size will be changed on your SBC value. Understand this concept. First of all, how to change your pedestal? Then you go for SBC value. Your pedestal will be automatic. You go for higher SBC, the pedestal size will be smaller. If the SBC is smaller, the pedestal size will be higher. That is the main difference for your value for your pedestals. Okay, this is the first point. This is the first point. It will be there. This is the carried the column by bearing capacity of the supporting soil. The next step, the minimum you go for residential structure, only you calculated the safe bearing capacity, SBC only. The safe bearing, how to calculate the safe bearing capacity? Borehole test. Okay, the borehole test. The borehole test, you take the sample soil up to 10 meters. Okay, up to 10 meters is a 30 feet. You take the up to 10 meters, then you calculated the soil conditions. For simple example, I will draw the one conditions. Okay, this is my one. This is my ground level. This is my ground level. Identify this is my ground level. So okay, this is my ground level. This is a 10 meter. This is a below ground. This is a above ground. This is a below ground. Okay, this is our below ground. First layer. This is a layer by layer. I will draw this layer by layer. This is my different layers. I simply tested on this is my borehole. I automatically my borehole will be rotate on this ground. I simply take this first layer. It's a clay soil. The second layer, you mark that soft soil. Then there's a hard soil. Then finally, it's a rock soils. Okay. Finally, is the rock strata. Then finally, you take my depth of my soil is a rock is a first clay soil 1.2 meter. Another soft soil is a 2 meter. Another hard strata is a 1.5 meter. The finally the rock strata is a total distance is a 7.7 meter. The below the ground level, my hard strata is a 7 meter. Then you excavate this 7 meter, then chosen for your file. Based on your higher depth, you choose this file foundation also. It's an economical one. Otherwise, you go for 6 feet depth, you will be choose this isolated also. Sometimes 14 feet, you will be go for isolated also. Okay, isolated. Some fillings also from gravel filling, soil fill, sand filling. Then go for your normal foundation. That is the main condition for your borehole test. The maximum you go for residential building, the borehole test is a compulsory. You take this sample, then will be occurs higher SBC, then excavation on this depth level, then excavation, then some stones and sand filling, then you put the normal isolated foundation for your buildings. Okay, this is the main step. The normal residential building, you go for borehole test. Take the different level. The next one is a large project. The large project is a big project like a industry building or education building. That type of building, it's go for plate load test. Okay. The smaller project, you take the borehole test, but you go for large project, you usually suited for plate load test. Now it's clear. Small project, you go for an borehole. Large project, you go for plate load test. Then black cotton soils are greater depth. Black cotton soils is a greater depth. So chosen for your pile foundation. This is my ground level. My excavation more than this may full of black cotton soils. My excavation going on about 10 meters. Okay, about 10 meters or 12 meters. More than converted into feet, more than 36 feet itself and above. So I chosen my foundation is a pile foundations. Okay, chosen my foundation is a pile foundation. That's also different types of piles are there. One is a concrete pile, timber pile, steel pile. There are so many types of piles are using. The maximum the concrete pile will be using on this clay soils. Okay, that is the third point. Your larger depth will be there. You will be chosen for your pile foundations. Okay, that is the main point. Next one, the columns are very closely. The spaced bearing capacity. The soil is a low raft. Foundation is a alter choice. Okay, why is choosing this alter choice means, see this, for example, I simply draw my one building plan. Okay, this is my building plan. I excavated my foundation. Okay, I simply draw my building plan. I simply draw my pedestal size. Okay, this is my pedestal size. The pedestal size will be high, so all the pedestal size will be merged. See this, automatically all the pedestal size will be merged. So the next condition is that I simply chosen for mat or raft foundations. Okay, mat or raft. The low SBC, the low SBC means automatically increase your pedestal size. Okay, increase your pedestal size, automatically the pedestal will be collapsed. You will be chosen for your mat or raft foundation. That is the main point. This is a pedestal size, automatically our this is for example 1 2 3 4 5 6 7, the 7 pedestals are there, automatically the 7 pedestal will be collapsed. So it's a low SBC. Low SBC means the pedestal will be high. But what is the another altered choice is directly go for mat or raft foundation is the altered choice for your buildings. Okay, the next one, the next point, the boundary lines are combined footing or stab footing will be provided. The boundary line. This is our area. See, this is our boundary. This is also same example. This is one of the block A. Okay, this is the block B. Okay, This is the block B. I put this nearby, I put this column for this combined block A and block B. So I put this nearby two columns are there. Automatically, nearby two columns is automatically the pedestal will be high. So its column, the pedestal will be clashed. So I provided the combined footings. Okay. Nearby two columns in this block A and block B, automatically your pedestal will be clashed. So it will be used for combined footing. Another one condition, another one condition. This is I create the two buildings. Okay, this is the two buildings. This is a new buildings. Okay, for assumption, this is a new building. For assumption, this is a new building. This is a existing building. Already it will be construction. Okay, already it will be constructed. This building is an existing building, but your client will be told that I starting from this corner, nearby corner, I am building will be started. So what type of foundation will be chosen? What type of footing? You simply go for eccentric footings. Okay, simply chosen for your eccentric footing. Says automatically I provided my pedestal, then I put this corner for this column. That is called eccentric footing. The two boundaries are same, you will be chosen for combined footing. Otherwise, you go for the different area. One is a new building, one is a exciting building. Means you chosen for your eccentric footing is a corner footing. You will be different. Design is a different. Okay, it's for another new building and exciting building also. This is the main point. You design your footing, you know that this all the main point also bearing capacity, what type of columns, and then greater depth of the soil foundation, and mat or raft combined footing also. Is already discussed about the step footing, slope footing, all the types. The next one, depth of the footing. There are three main checks are there in your footing. Once you design your footing, three checks are main. Check. Three checks are main. Okay. One is the depth of bending moment. Okay. One is the depth for bending moment. Bending moment. Another one is a one-way shear. Is a compulsory check for your footing. One-way shear. Another one is a two-way shear. Okay. Another one is a two-way shear. These three checks are main for your footing design. One is a bending moment check, another one is a one-way shear, another one is a two-way shear. These are the three checks compulsory main for your foundations. Okay. This is automatically so many checks are there, but is the main check is the footing for bending moment. Another two-way shear, another name is a punching shear. Okay. This is a one-way shear. The two-way shear is a punching shear, another name is a punching shear. Okay, one is a bending moment, another is a one-way shear, another one is a punching shear for your buildings. Okay, this is the main three checks to develop your buildings. Check compulsory check. Okay, this is a this is the checks acting on your pedestal. Which area will be the bending moment, that type of force will be acting, one way shear and punching shear. Okay, the bending moment, that type of critical section for your bending moment act on this one, this half of this portion. This is our pedestal, this is our column, this half of this portion acting on this bending moment. The next one is a one way shear. Next one is a one-way shear. The one-way shear is acting on this, the one third of the portion of this corner. Okay, one third of this portion of this corner of your pedestal. That is called one-way shear. The punching shear is acting on this around your column. The punching shear is acting on this around this column. This is our column. The punching shear is acting on this column. The bending moment check. The bending moment check will be failure. Okay, the bending moment check will be failure. How to save for your bending moments? Increase your depth for your footings. Okay, increase your depth for your footing. Automatically, the bending moment will be passed. See this automatically. This is our pedestal. See, this is our full of pedestal. Then this is our column. This is our depth. This is our depth, overall depth for your footing. This is the depth. You suppose sometimes you will be the failure in bending moment. You will be sometimes I got 200. This is failure to increase the depth of your size also. I simply put 400. It's automatically safe for your bending moment and other also. Then is a depth is a minimum values are there. Minimum value of the depth is 150 mm. Higher you will be provided based on your soil condition, load and moment. But the minimum value is a 150 mm. Okay. The minimum value is a 150 mm for your foundation. So okay, this is our minimum value. You refer that SP34 also. You refer that SP34 code book. The minimum value is a 150 mm. The maximum you go for your based on your depth and all the things. Okay. Next thing, this is the checks for your bending moment occur in this area, then one-way shear and two-way shear. This is the minimum thickness for your footing. The stable is taken from a National Building Code, NBC 2016. This is a National Building Code, NBC 2016. This is a minimum. This is a lightly loaded structure, 150 mm thickness. Then you go for reinforced. Our structure is a reinforced. Reinforced structure. You go for resistant soil. Resistant soil, the minimum depth of the footing is a 150 mm. The resistant file you go for 300 mm. Okay. This is the main condition. It's taken from NBC 2016, page number 21, National Building Code. It's available on this internet. Please download and refer that. Okay. The minimum thickness for your footing is a RCC means 150 mm. For your file, you go for 300 mm. The next one is the sample taken. Suppose you will be go for test for your soil conditions. Okay, soil condition. How much flow will be taken for your sample? You go for identification, natural moisture content test, or mechanical analysis. Index properties for cohesive soil means you take the 1 kg. Then chemical test. The sand and gravel you take the 3 kgs. Compaction test. The compaction test means your soil is a cohesive soil and gravel soil. It take a 25 kgs. Cohesiveless and sands are 25 to 50 kgs. Gravel soils are 50 to 100 kgs. Okay, compression exam. This is a test. This is a soil condition. This is a sample will be taken. This is in kg. It's also taken from National Building Code 2016. Once you tested for your soil, the kgs will be given. Yeah, I simply go for taken the chemical test. My soil is a sand and gravel. I take the 3 kg sample, then go to test my soil condition. It's a very important. What type of test will be used and its sample will be taken. So, okay, this is important one. The next one is a settlement, allowable settlement, maximum settlement. In our foundation design, it's take a 25 mm settlement for our foundations. Okay, it's take a settlement minimum for settlement is taken for 25 mm. Okay, 25 mm settlement will be taken to design the all the buildings also. 25 mm. The maximum settlement for reinforced concrete is a 75 mm, but it will be designed for 25 mm minimum. Will take a 25 mm settlement also. This graph are taken from NBC 2016. These are the some pictures for your eccentric footing. See, this is our another building. This is one of the exiting building. This is our new building. Since it's automatically is provided this corner footing. Its name is called eccentric footing. This footing will be provided. Then is a column. This beam will be provided. The beam infra reduce the resist the uplifting force for this column. So this beam will be provided for connected with one column to another column. Sometimes it's connected with column end with this side also, end of this pedestal. One side with connected with column, another side end with the pedestal. Sometimes it's connected with all the columns. Okay, this is the column deflection. It will be connected with all the columns. Okay, it will be connected. This is called eccentric footing. This is the different types of eccentric footing is there. This is a normal isolated footing. The single column says automatically this is our normal isolated footing. It will be taken. This is a simple method. This is the center of this column. That is a eccentric is the corner column. Says eccentric is a corner column. This portion is the center of your column. That is the difference between eccentric and this type of footings. Okay. This is another type is a spread footing. The spread footing is a heavy footing. Heavy type of foundation is chosen for your spread footing. Normal lightweight structure is used for isolated footing also. Otherwise, you will be go for heavy. You chosen for your spread footing also. These are more than different types of all the footing, isolated footing, step type footing, and all the type of footings are available. This is another one. This is a mat or raft footing. This is all the columns in this one pedestal. This is called mat or raft footings. Okay, understand this. Mat or raft footing, all the pedestal will be combined with the one footing. That is called mat or raft footing. This is also mat or raft footing. Next one is a pile. The pile is a main thing is a pile and pile cap. The pile is a different types of piles is a timber and a sheet pile is the timber, concrete, steel. That type of piles are the pile cap is based on your number of piles. It will be different. The pile cap is based on your number of piles. Is the 3 pile cap is there, 4 pile cap is there. I simply this my concrete pile. It is taken into higher density, not a medium density, low density. It's an expression into higher density. Then this is my 4 pile. I chosen for 4 pile cap, 4 number of pile cap. Then normal structure, normal column will be go on it. That is a important one. This is the pile. It's a this is a below the pile is there. This is the above the ground for your pile. This is our pile cap. See, this is our pile cap. Then this is our normal column. Okay, this is our pile cap. This is our normal column. Then it will be used for beams and columns, etc. Same like that. That is the normal pile cap. Then this is our normal column. This is also one eccentric footing, the corner type of footing. It will be provided. This beam is connected with one end is a column, other end is pedestal edge. There is a main one. The two types will be using for this eccentric footing. One is connected with column, is another side is connected with all the columns also. Another one type, one is connected with column, another one is a ended with pedestal edge. That type of ones. Okay. The next one, sometimes we will be calculated the subgrade modulus. The subgrade modulus is a formula is the SBC into directly your stat pro means directly give the SBC value. You go for E types, that type of software, you calculate the subgrade modulus. How to give the subgrade modulus? The SBC into FOS into factor of safety by settlement. Okay, SBC based on your soil condition, factor of safety of soil is a 3, the minimum settlement is a 25 mm. You automatically calculated the subgrade modulus for your soil. Now it's clear how to calculate the subgrade. E types only will give the subgrade modulus. Stat Pro will give the only SBC value. So that is a different. This is a reinforcement for your reinforcement for your isolated footing. There is a minimum thickness for your 150 mm. The cover, all the sides will be given. You simply refer the SP34 code book. It will be given the all the details for your isolated foundation and combined and pile. All the types of all type of foundation reinforcement are given in this SP34 code books. It will be refer. It take easily. Okay. Another one simple question. This is our riverbed area. Okay, this is our riverbed area. The nearby the dam is 100 meters, just 100 meters nearby the dam. Okay, this is 100 meter nearby the dam. What type of footing will be chosen for this column? Anyone, what type of footing will be chosen for this column? This is a riverbed area. River will be going on this. In this near my area, this bridge will be going under construction. This is a riverbed area. Nearby 100 meter, the dam is there. So what type of foundation will be chosen for this area? What type of foundation? Anyone? Simple. The type of foundation is a normal isolated foundations. Okay. This riverbed area also nearby 100 meter dam is there, but is chosen for your normal isolated foundation also. Why? The soil is a hard strata, rocky strata. So it's chosen for this hard strata. So it's a normal isolated foundation. See, this is the below the ground level. See, this automatically is a fully hard strata, rocky strata. So it's chosen for this normal isolated foundation also. First of all, you will be soil test. Any building you will be designed for this. First of all, you go for soil test. Then you will be design it. But it's a riverbed area. But the SBC is a high. So it's chosen for this normal isolated foundation. This is our riverbed area. It will be excavated fully rock area. Then it will give the normal pedestal foundation. See this automatically. It will be give the pedestal foundation. Then go for normal columns and piers and etc. Okay. This is the important one for your soil test. Once you tested the soil, then go for any residential building or commercial building. Sometimes the client will be my soil is a 250. It's like assumption, but you design for 250, but the original the SBC value is a 130. Automatically the structure will be collapsed. That is the main problem. So once you design will be start, you will be check compulsory check for this SBC value for this area. Otherwise, you nearby area, you see this nearby area, how many SBC value. Otherwise, you excavate that soil. How many feet it will be go for that? What type of soil will be there? Yeah, I simply excavate that 4 feet. My rocky soil is there, so you go for normal isolated. Then I go for 14 feet. That type of its soil will be different. Okay, the soil test is a important one for your buildings. Okay, this is the soil test. Okay, now it's clear. This is the basic elements for your building design for your manual one. There is a different types of soil is there. Manual check is the this is the resistance IS 456. The depth of the bending calculation is a two-way shear and one-way shear is the main check for your calculations. Okay, this is the main check basic needs for your manual design slab, beam, column, and footing also. Okay, now it's clear. These are the how to identify footing and all the things for your structures. Next, I tell about something about the earthquake. Okay, I tell about earthquake. The basically you calculation for earthquake is taken into mass, not a load. Okay. First of all, you go for any earthquake analysis. You taken as a weight for this structure, not a load. You take a weight. You calculate it by building weight, then go for your earthquake analysis. Okay, this is the main thing. The next one, there are two types of analysts are there. There are two types of analysts. One is a equivalent static method. Another one is a dynamic static method. Now discuss about the dynamic static method. The dynamic static method is finally you calculated the base shear value and lateral force values. Okay. So finally you calculated the base shear value. The earthquake effects on your buildings. Okay. Finally you calculated the earthquake effect and lateral force also. Same like that earthquake force, how much force will be acting on your building, that is called lateral force, and base shear. Finally you calculated the base shear values, then you will be resist for your buildings. Okay, finally you calculated the base shear values, then you calculated the resist for you chosen for a retrofitting or a normal damper, seismic dampers, viscous dampers. There's so many dampers are there. Otherwise, you go for base isolation techniques. Are so many techniques are there. You will be chosen once you calculated the method, equivalent static method. Finally, you calculated the lateral force and base shear. You simply will be calculated the different types of methods. Okay, this is a basic thing methods. Then there are RC structural walls. The RC structural walls, if resist the shear walls also resist the earthquake forces. Okay, the shear walls also resist the earthquake forces. One is the ordinary RC structure wall. The ordinary RC structure wall is a reinforced concrete RC structure wall designed and detailed as per IS 456, but is not meeting a vessel detailing requirement. You go for earthquake design is a detailing requirement as per 13920. It's ordinary RC structure wall. It does not need the IS 13920, but you need the special RC structural wall. You go design for 13920. This is the main one for your walls. The next one is the two forces are acting. One is a horizontal earthquake load, another one is a vertical earthquake load. The two loads are there. One is a horizontal earthquake load. This is the horizontal earthquake load. The vertical earthquake effect. How to which place will be the vertical earthquake effect will becomes your structure located on seismic zones and 4 and 5. There are four zones are there. 2, 3, 4, 5. There are four zones only. The earthquake zones are available in India. Okay, four zones. How to calculate the vertical earthquake? The structure located in seismic zone 4 or 5. Then you go for structure will be vertical or plan irregulation rested on soft soil bridges. Maximum the bridges will be is calculated for both horizontal and vertical also long span stretches. The type of stretches will be calculated the both vertical and horizontal earthquake effects. The next one, already I told that the earthquake analysis you calculated the weight only. Then how to convert the live load as a weight? Simple method. My live load is up to 3 kilonewton per meter square. I take the 25 percentage of the total weight of the building. My live load is above 3 kilonewton. I take the 50 percentage of the total weight of the building. This is simple calculation. Okay, all the materials will be calculated by weight. So my live load is a 3 kilonewton. I take this 25 percentage of the weight of the building, and above 3 kilonewton, it's calculated the 50 percentage of the total weight of this buildings. Okay, these are the some checks for your earthquake analysis. There's some check. First one is a accidental eccentricity, base shear, story drift calculation, stability index. These are the formula we'll be using for this calculation for this accidental eccentricity and story drift and all the things also it will be given. These are the calculations I already discussed about the one way and two way. The finally I tell something about the detailing. How to prepare the sheets for beam layout, keep and step by step procedure. First, which plan will be created and how to find the reinforcement detailing and all the things. Okay. First of all, you will be created this key plan. This is our key plan. You created the column beam. This is a grid line 1, 2, 3, 4, 5, 6. You mark the dimensions also. The first you will be created the key plan for your building. This is the first step. The first step will be calculated the key plan. The second one is a column layout. The second one is a column marking. The column marking, the mention the column name also. The second one is a column layout. The C1, C2, C3, the type of column layout. The next one is a column reinforcement. The third step is the column reinforcement. That type of you will be marking for your column reinforcement. Next one is a beam layout. This is our beam diagram and a dimension will be given for your diagram. So okay, beam number B5, B6 size is also given in this diagram. Next one is a beam layout. Next one is a beam reinforcement. This is automatically the reinforcement is a longitudinal section. Then is a cross section. You provide the longitudinal and the cross section for your beam design. Also, this is a beam detailing layout. This is a reinforcement. Then you go for slab detailing. This is our slab. Already I told that one way slab is a mention the symbol for direction of two sides and the thickness. This is our two-way slab. Two-way slab is load direction into four sides. This is a one-way slab. This is our two sides. This is a four side. This is a thickness will be mentioned. And then slab name also. Then slab name also. This is our slab layout. Then this is our slab reinforcement mid-span support mid-span and support also. Two conditions. This is our thickness for your slab. The name of your slab. Okay. This is mention the remarks which one is a one-way slab or two-way slab. It will mention for this side also. This is the footing layout. You mentioned this normal F2, F5. These are all our isolated footing. This is our raft footing. See, these four columns will be on this single footing. That is called raft footing. The maximum the type of building, the raft footing will be used for lift purposes. That type of purposes, the raft footing will be used. Okay, the type of purposes the raft footing will be used for your buildings. Then this is our normal footing. This is also normal footing. Another one, this is also circular column footing. This is also footing F1, F2. This is a combined footing. Mention this longer footing. This is called combined footing. It will be mentioned. Then this is also raft footing. I mentioned this footing layout also. This is our combined footing. This is also combined footing. Normal footing, it will be mentioned. This footing layout. Finally, you draw the footing reinforcement detailings. Okay, this is the one type of layout. You prepare the another type also. See this. This is our ground floor roof beam. Mention this beam and name. This is our slab reinforcement. See this longer span one-way slab and a two-way slab also. Automatically it will be mentioned. The two-way slab, the two direction will be load will be transferred to reinforcement will be calculated. This is a beam reinforcement for this building. Then slab reinforcement. You provided the slab design and all the designs also. This is the basic procedure to design for your manual and other calculations for your buildings. Okay, understand how to calculate the slabs and beam basic things and columns finally as a footing. Then how to prepare the sheets also, layout, column marking, column reinforcement, beam marking, and all the things. Then you go for your analysis. Next step. Now itself I complete this today's section. Then tomorrow will be discuss on and software stack, how to analyze the beams, columns, and slabs, etc. For this tomorrow section, we start the software classes. Then you will be analyze the one framed structure for your buildings. Okay. Now itself I complete this section. Now itself I put the feedback link on this chat box. Please fill this feedback and attendance form. Tomorrow will be discussed on this software also.